Okay guys, so I want to just introduce the parent functions of cosine, sine, and tangent. After we draw these, they should look pretty familiar since you saw them all last year. But in order to graph them, I first want to get sort of a table of points. And I say that cosine, sine, and to some extent tangent, they have 5 important points. And while I don't expect you to make the table every time, I do expect you to know where the important points are on both or all 3 graphs. So theta, if theta is 0 degrees, what's cosine of theta? So what's cosine of 0 degrees? So what's your x coordinate at 0 degrees on the unit circle? Well, it's 1. Cosine of 90 degrees, so what's the x coordinate at 90 degrees? That's 0. Cosine of 180 is -1. Cosine of 270 is 0. And cosine of 360 is back to 1. Now, you know, we are very much used to thinking of trig functions on, the unit circle here. But basically, we can take their values all along the unit circle and plot them on a coordinate plane. And that gives us a very unique type of graph. So if I take these points and I plot them at 0, 1, you got right there. At 90, y value 0. At 180, -1. 270, we're back at 0. And 360, we're back at 1. Now, we don't want to connect these points with straight lines. They have a little bit of a curve. What we have right now is just one portion of the cosine graph. And basically this shape, sort of like a wave, it repeats itself. It continues that shape in this direction to the left and in that direction to the right. It repeats itself over and over and over again. It really never ends. Much like ocean waves really never end, the cosine wave doesn't end. When we look at sine, it's going to look very similar. We're going to fill out this chart. This time I went ahead and mixed it up. I did radians. So I do expect you to know how to graph these both in degrees and radians. So 0 radians, sine of 0 radians would be 0. That's like asking the y coordinate on the unit circle at 0 radians. At pi over 2, that's the same thing as 90. The y coordinate there is 1. At pi, it's 0. At 3 pi over 2, it's -1. And at 2 pi, we're back at 0. So again, these are the 5 important points that I would expect you to always be familiar with. And we're going to go ahead and plot them. So we plot our coordinates and then we connect with a nice curved line. Same idea from cosine. You can see it's just sort of shifted a little bit. But we would repeat this shape forever to the left and forever to the right. So again, just like an ocean wave. So you can see that cosine and sine are, very similar to one another. They have the same general shape. It's just one sort of shifted further down the x-axis. Tangent is always the oddball. So taking a look at tangent. Tangent of 0 degrees. Remember, tangent is y over x. Okay. So if I take the y value at 0 degrees, which was 0, and I divide by the x value, which is 1, I still get 0. Now, tangent of 45, that's actually pretty nice. Square root of 2 over the square root of 2 divided by the square root of 2 over the square root of 2, square root of 2 over 2 divided by square root of 2 over 2, that's 1. Now, interesting, at 90 degrees, what happens? We end up with 0 on the bottom. You get a 1 over 0. That is undefined. At 135, we got a value at -1. At 180, we're back to 0. So let's plot some of the points we know. We have a point here at 0, 0. 45, 1 would be actually about halfway between those two tick marks. 90 is undefined. Then we got a point again at 135, comma, -1, and then 180, 0. Now, 90 degrees is undefined. Well, that actually means there is an asymptote right there. And there's actually going to be another one again at 270. And I'm going to put another point right here. And I'm going to draw this in. As soon as I do, I bet you recognize it from last year. What you have right there is one cycle of the tangent graph. And basically this repeats itself over and over and over again. And so we're going to have another one right here. So on and so forth. So you need to know how to draw all three of these graphs, both in radians and degree measure for each one, which we'll be practicing in the upcoming days. It shouldn't be too bad for you.